evening, and thanks for joining us at the TI Technology webinar hosted by Texas Instruments. I'm really excited to get, again, another webinar to get me ready for the school year. This time we're going to be taking a look at TI-Nspire technology and ways that you can help build your students' confidence. I know many of my students come to me lacking confidence, so I'm really looking forward to what Audrey and Josh have in store for you. My name is Mike Houston, and I'm a moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make those tough to teach, tough to learn concepts accessible to all my students. In fact, we're lucky to be joined by two panelists, Audrey Tucci and Josh Mize. Audrey is a TQ national instructor and math educator for a public school in New York. She's taught a wide range of courses from 8th grade all the way up to AP calculus. She was named a master teacher for New York State and is the K-12 curriculum coordinator for her district. She loves having the opportunity to educate not only children, but educators as well. Audrey, it's great to have you with us.
It's been a while since I had to do online stuff, so hi everyone, happy to be here.
Audrey, we can't hear you. Maybe I can't hear you. All right, so hopefully audio is good. Josh is in his 23rd year of teaching in Howard County Public Schools in Baltimore, and similar to Audrey, he has also taught a very wide range of math courses. He taught everything from Algebra 1 up to AP Calculus and AP Statistics. Josh has been a TQ instructor since 2003 and engages in instructing teachers on how to integrate technology into their classrooms as much as he enjoys teaching his students. So Josh, it's great to have you with us.
Thanks, Mike. Folks, happy to be here tonight. Happy New Year for those of you who have had your summers cut short and are already back in the classroom.
And at this point, Audrey, would you discuss our agenda for tonight?
Sure thing. Doesn't seem to be turning for us, Mike.
Cool. Okay. Well, let me try that. Does that turn for you?
Nope.
Okay. Well.
But I can wing it. I'm good at winging it.
Yeah, let's do that. Let's wing it, and then let's hope that whenever we give you control, that we can see your screen. So let's talk about some building concepts and Math-Inspired and what we're going to see tonight.
Yeah, so tonight we're going to take a look at a few different things. We're going to look at some activities from building concepts, and we're also going to look at some from Math-Inspired. And sprinkled in between those two is we're going to kind of focus on some calculator skills and some activities that will, there it is. Now we have it. That will build, now it's gone, that will build your students' motivation and confidence in their foundational skills as we get back into this new year after kind of a weird few years in education. So we're hoping that this will either be a nice way for you to review concepts that you hope your students already know, or introduce new concepts right from the get-go. We're also going to be talking to Mike about the webinar drawing at the end of the webinar.
Thanks so much, Audrey. Yeah, be sure to stick around. We'll be giving away to one lucky winner a TI graphing calculator. So be sure to stick around to the end. And Josh, we talked through a couple things that hopefully we're going to be able to do at the end of the webinar.
Absolutely. Folks, by the end of the webinar, we're hoping that you are going to see that these activities we're highlighting tonight, along with the many others that are available on the TI website, are really seamless and easy to integrate into our classroom. They help build student confidence because of their minimal calculator skills that they need, but you're going to take away those calculator skills. And then you're also going to be able to find your own engaging resources in both the building concepts and the math-inspired portions of the TI website.
Awesome, Josh. Thanks so much. Audrey, you have control. Feel free to share your screen.
Sounds good. Okay, so the first activity we're going to take a look at tonight actually comes to us from the building concept site on the TI website. So the one I wanted to kind of look at to start off with, these lessons are designed to teach new concepts to junior high students. However, I typically teach high school classes, and this is something that I might use in a pre-algebra, algebra 1 class, or even an algebra 2 class, where I reintroduce the idea of expressions, equations, and variables in order to build onto that to get to things like evaluating rational expressions or composition of functions as I go a little bit deeper. So this activity I wanted to highlight in particular because it's a great reintroduction or introduction to variables for our students. Now, what's nice about these resources is when you come to the page, it gives you a nice little short video of kind of what's going to be included in that calculator file. It gives you that vocabulary that they really want to highlight, and a standards alignment, which we know a lot of our districts want us to have available. And then down below, we have our downloads. We have everything as a zip. We have a student activity that goes along with the calculator file, which really includes some incredible questions to guide the students along. And we also have teacher notes. I'm going to take a peek at those in just a moment. And then, of course, the calculator file, which we're going to work with as well. So taking a look at the teacher file itself, this is an example of this first one. What I like about this is it certainly goes through and again highlights those key pieces. So if you look on this first page, it gives you this breakdown of the vocabulary that we really want our kids to be focused on: expression, variable, constant, and it even gives you those definitions for you. This is probably the longest teacher document I have seen. It is the most thorough teacher document that I have seen with a calculator file. So I was impressed by how deep they went. They do give you a lesson pacing. Now, I would say this is if you're teaching it right from the get-go and the kids know nothing about expressions, variables, constants. If I was using it in an Algebra 1 classroom, it would be a reintroduction, so it may certainly go quicker. And then on page, I have my notes, on page 2, we see where we start to see the suggestions and how they suggest you use it. They suggest you do this activity in small groups within your classroom. And as we continue to go on page 4, they even give you the tech tips that are needed for this activity, which is really cool. So there's your TI-Nspire tech tips right off to the side. The kids will have to be able to utilize the menu, the tab button, your plus and minus button to change operations, and then control delete to reset a page. So it gives you those TI tech tips right there for the teacher so that you know how to guide your students when you're looking at this document. So let's take a peek at the TNS file itself. So I'm hoping we can see this. And if not, somebody will yell at me, I'm sure. Yes, thanks, Josh. Okay, so we have a TNS file, and when I present to my students, I like to have my software up on my smartboard for them to see. So I have my calculator emulator on one side, and I have the slide screen on the other. And then over here, what I have is I have the student document. So the student document is something that you would give along to your students with the TNS file so that they can walk through each slide and answer questions that go along with it. So what's really cool about this file is it starts off, it gives you a number line, and it's asking you, do these values of X make this statement true? Oh, look, I'm looking at the wrong one. Just kidding. So 1.2, it's going to give you some directions on how to work with this TNS file. Moving the dot will change the value of X. To change numbers, cursor over a number, and you can change the actual expression itself. Or you can press plus or minus to change the operation, which is pretty cool. When we get into this, it starts by looking like something like this. So we have an expression 3x plus 4. If I hover over the 3, a little pencil pops up. And all I have to do is click, and it allows me to change that value if I'd like. I'm going to keep it at 3 for now. Okay. again, I can press the plus or minus, and it's going to change my operation. Notice it changes to plus -4 instead of plus positive. So it changes to increase. So I can unmute your audio. So then what we can do is we can take that point on the number line, and as we move the point, notice it changes the value that's being substituted into the expression. The expression is then using order of operations step by step to evaluate the expression at the given value of x. So as you go along with this activity, it says what value of x will the expression always be a multiple of 4? Well, 16 is a multiple of 4, and the x value is 4. So what's another multiple of 4? Well, 28 is a multiple of 4, and the x value is 8. So they start to find these patterns within the expression itself, which is something that we really are looking for our students to be able to do. This is going to baby step them through it a little bit at a time. So as they continue on in this document, the questions become a little bit more. Now we're moving to page 1.3, which I'm already on. The cost of a yearly membership in a book club is $10. Downloading a book costs $2. This represents the number of books downloaded. Enter an expression for the cost of buying books through Book Club A and check your answer with the file. So this is where they're able to then go in and say, okay, well, if it's $2 a book, that means this has to be 2, hopefully. And this, if it's a yearly cost, should be 10. Right? So we're hoping that now we have this expression, and how many books could I buy if it's going to cost me what it's going to cost if I have 13 books? So they take this slider, they move it over to 13, and now we've got this idea of, okay, now I can take the simple idea of substituting into an expression, given a value, and bring it into a real world. So really neat kind of activity that just gets them introduced the idea of a variable, of substituting in, of evaluating, and then extending it into real world application. Now, if I were doing this in an Algebra 2 classroom, the question that might come up next is, okay, so we're doing rational functions, and I know that we have rational functions that have multiple variables. I have an x, I have y, I have an a, I have a b. Is there a way to use my calculator to evaluate without this idea of a slider or without having this file in particular? So now we extend beyond this idea of building the concept. Now they've got the concept of substitution. Is there a way for my Nspire to help me to check my work once I have a rational function and I'm using multiple variables? So let's show you a little bit about what this Nspire can do in terms of evaluating an expression. All I'm going to do is I'm just going to insert right into this calculator, into this document, because I can. I'm going to add a calculator page. And let's say I have a rational function and we're going to use a, because remember, it's not always x and y. And I'm going to store a as -2. And then I'm going to have b, and I'm going to do the same thing. I'm going to store that as 3. And I'm doing control math template. That's my preferred way to store. There are other ways. You can use the such that notation in order to write it as well, and people really like that method. I can show you that after too. And what we can do now is we can just put in our rational expressions. So control divide, I'm going to put in my fraction template. And if my rational expression was a squared times b divided by a plus b, I can simply type that in, and I've got my rational function evaluated. Okay, so we're going from that idea of, okay, I know what the values are coming from the number line. I can take that, I can substitute it. I'm a hand talker, I apologize. I can substitute that into an expression and see how it builds down. Then I can extend it into something like Algebra 2, where we're dealing with multiple variable and using my tools to evaluate for me. We can even go a little bit beyond that if we get into the idea of composition of functions. And if you have a CAS, we know that, CAS will do variable manipulation for us. So what if we have a function and we want to find f of g of x? We have 2 different functions. can the calculator handle that? Well, surprise, surprise, it can. So I'm going to walk you through that as well, and then we're going to take a peek at another activity. Josh, how are we doing? Any questions popping up yet?
All good so far, Audrey.
Okay, feel free to stop me if you need to. All right, so if we're going to define a function, we're going to use the define command in the calculator. We're going to go into our menu. We're going to go actions, and we're going to go to define. So let's say I have a function f of x. I'm going to type in f of x equals, and I'm going to tell what my function was, 2x plus 3. I'm going to hit enter. So now my calculator is reading that f of x as the function 2x plus 3. I'm going to follow that same step to insert my g of x, menu, actions, defined, g of x equals, let's do x squared minus 9. Now again, I'm using a CAS. So in a pre-calc classroom, in a calculus classroom, in a statistics classroom, many people will use CAS. I know I teach in New York State, so we cannot use CAS in our Algebra 1, Geometry, or Algebra 2 classes. We don't allow it on our state assessments, so we don't use them in class, unfortunately. But if you teach an upper level, this could be fair game. So now I'm going to simply put in my composition g of f of x. And I'm going to hit enter. And there's my composition. So bringing that idea of substitution, for me, I would love to take this activity and use it in my pre-algebra classroom where they may have already been introduced in 6th grade to evaluating a function, but they need that refresher at the beginning of the year because after a summer, it's since gone poof and kind of went by the wayside. So we reintroduced that idea of, just evaluating a function with a specific value of x, bringing it to the real world situation, like how many books can I buy? And then bringing it again into Algebra 2 with things like rational functions and beyond when you're dealing with things like composition of functions. So those are just a couple of tools that are available to you that you could use to extend beyond this building concept activity. How are we doing? Do we have any questions? I don't see the chat, unfortunately.
Nothing in the chat, Audrey.
Okay, cool. All right, how are we doing? We're okay. Let's keep going to, we're going to take a peek at another activity. And this activity comes to us from, not there, comes to us from Math-Nspired. And Math-Nspired is another site where I love to go find activities. It's probably my all-time favorite. There's so much here to use for your classroom where you don't have to reinvent the wheel. It's already built for you. And these are all action consequence activities for your kids to really do some discovery learning. So one of the files that I really like is this Algebra 1 variables on both sides. What I'm noticing as a high school teacher is after a few years of virtual learning, hybrid learning, just a kind of a mix bag for the last 2 years, my students' equation solving skills are rather weak. So this file is one that you can use to kind of reintroduce the idea of when we're looking at equations, can you have one solution? Can you have no solutions? Can you have an infinite number of solutions? And it allows students the opportunity to discover that on their own without me as the teacher saying, okay, solve this equation. How many answers did you get? Solve this equation. How many answers did you get? And you let them figure it out on your own. So just like with the building concepts, we see that we have a list of vocabulary that we're going to stress. We have our objectives. It has a short about the lesson. And then off to the side, we have all of our files that we can use. So we have that student PDF, teacher PDF, and then calculator file. So let's take a peek at that teacher file. So the teacher file here, same idea. We're going to give you a list of those vocabulary, your objectives. We're going to give you those tech skills that your kids are going to need in order to be successful with this. So what you're going to need to be able to do is you're going to be able to open a document. You have to be able to move through pages, control right arrow, control left arrow. You have to be able to grab and drag a point. This tip is quite helpful with the handheld set to medium, because if the font is larger, I think you get some weirdness on the screen itself. It doesn't fit quite right. And then the last one is you can hide the function entry line by hitting Control G. And in my classroom, we're big on shortcuts. We say Control G. G stands for graph. So do I want that graph bar to be up, function bar to be up? We hit Control G. It brings it up and down. So that's something that we can look at as well. As we move to the TNS file, let me bring up my student document so I can have it side by side. Again, we have a student document that's going to go through and build with them through the lesson. And I already started to show you this because I opened up the wrong one from the beginning. So move along a number line to observe the changes in the values of the variable expressions and equations. So you hand this out to the students. This is not something that I would walk them through. I would simply send them the TNS file. I would give them, yeah, I always use that too. I like it. I would give them the student document off to the side, and I'd say, okay, you guys are on your own. Let's see how you do with this. And honestly, they do quite well. I'm trying to just resize. I apologize. Okay, so we've got our TNS document off to the side. I know I have to be able to grab and drag. So again, just like with that evaluating functions one, we're going to be dragging on that number line. And I love that we're continually using the idea of a number line because it stresses the understanding of integers. And that's another skill that they tend to be weak on when they come up. So we're going to grab and drag, and we have an equation with variables on both sides. 2x minus 4 equals 2x plus 1. And then notice it says false underneath it, underneath the equal sign. And then I've got the expression, and we're showing again that substitution into both sides of this equation. So as I grab and drag this, my hope is I'm going to get a true. And we're going to peek and we're going to look around to see, okay, I don't have it yet. I see how they're evaluating. Am I getting closer? I'm all the way to 10 and I didn't get it. So let me go back and let me go in the opposite direction. No, 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 no. Do I have any? No, why don't I have any solutions, right? So this becomes a conversation that you have with your students. Guys, why don't we have anything that says true? What's happening? So without them even solving this equation, they're looking and they're saying, well, none of these answers work. So what is it about this equation that makes it so nothing says true? And then we get into this idea of we don't have any solutions at all. So how could we then extend beyond this and say, okay, if I don't have any solutions at all, why don't I have any solutions at all? What's happening with the left-hand side and the right-hand side of this equation? And then you can start talking about things like systems of equations, right? So if we have something like this, I have 2x minus 4 and I have 2x plus 1. What if I want to look at it graphically? Let's extend beyond. So, okay, I'm going to add a graph page. And I'm going to graph 2x minus 4. Enter. And then notice my graphing bar went away where I typed it in. So I'm going to hit Control G. That was a tip that was given to me on my teacher page. Control G, there it is. And 2x plus 1. So now I'm looking at them graphically. Well, guys, why don't I have any solutions at all? Well, the two lines are parallel, and we know, hopefully, that if they don't intersect, I don't get any solutions. So it's a way to extend beyond this really cool file that they're given to check their understanding it. So if we're stuck here as a class and we're saying, well, I don't get it. Like, why don't we have any solutions? How can we build beyond that and keep building those concepts? The idea of substitution, or the idea of, okay, the left-hand side of the equation really could be looked at as a function, and so could the right, and look at it as a system. So as we build on this, we go to the next page and we see this one here. So now I'm going to grab and drag, and I'm hoping I get something, right? I don't see anything yet. I'm hoping I'm not in the same situation. I'm going to keep going, keep going. There's a true. So now we already looked at that graphing piece, and we know that the two parallel lines didn't give us any solutions at all. But what would this do for us? So maybe from here, we want to talk about, okay, so if this is a system of equations, is there a way for my calculator to help me check to see if this is indeed true? So let's look at a system solver. I have to rewrite this down because I lose things on the paper. So I'm going to now insert a calculator page, and let's take a look at this linear systems. So we're going to go into my menu, and we're going to go into algebra. And I'm going to go to solve system of equations. Okay. They are both linear, but I can keep it as solve systems of equations if I'm not sure, because sometimes our kids aren't quite sure if the vocabulary is there or not within your class. Maybe they've forgotten what linear means, which is totally possible when we're building concepts. The number of equations is 2. The variables I'm using in particular are going to be x and y. If we've already talked about, okay, this one side of the equation could be a y equals, and the other side could also. And we're going to actually type these in. So we've got y equals 2x minus 4. And I've got y equals 3x plus 1. And now this is not a CAS feature. This is on the numerical as well. Okay. And I'm going to hit enter. So notice my x value says x is equal to -5 and y is equal to -14. So as I go back and look, well, when x was -5 and I substituted that x equals -5 into my equation, I ended up with outputs of 14 on both sides. So my system solver verified for me that my substitution was indeed correct. So kind of a cool way to look at things. So one more of these, what happens when we have something like this? So automatically it says true. That's kind of cool. Do I have to go any further? Well, now I'm curious because I got one that said false the whole time. I got one that said true just once. And now I have this one. And as I go through, notice what's happening. It's true everywhere. But why? Yeah, right? So what would your students, what do you think your students would do? Put it in the chat. What do you think your students would do to verify that it works for every single value of x? Are they going to go through and substitute in every single value of x that exists? What are their options? What could you show them as a teacher to make sure that they understand that they can verify that this can give you an infinite number of solutions? Yeah, they can absolutely do it graphically. Okay, so if they do it graphically, math teachers, what should happen? Yeah, it's the same line, right? And I really like that graphing option, right? So the other piece that I wanted to hit on, and we have one more minute before I have to give it to Josh. Let's go back and take a peek at this question here where we had a single solution, right? So when we're looking at this one, you're right, you can absolutely do this algebraically, and you could do it using the system solver. But how do we do this when it is graphical? Because we do want to make sure that they can do this graphically as well. So again, this idea of graphing, Control G to bring back my function line. How can we go about and find this point? Now, the first thing I notice is, well, I can't see it, right? What do I do if I can't see it? I got to change my window. So we have a couple of different options. And this is what's really cool about this calculator is I have one option where I could control click and grab this and swipe up. And it's just like grabbing the paper and moving it around. Okay. I'm going to control Z to undo it because I want to show you another way. I could double click here and change this to, well, let's keep it -10. I'm going to hit tab. I don't really have to change the Y maximum. And I'm going to scoot around until I get to that Y minimum. And I'm going to say, well, my answer was supposed to be at -5, and I don't remember what it was off the top of my head, 14, -14. So I'm going to go to -20 because I think I should be able to see it. Oh, I see it now, right? So we very quickly changed our window. So now I want to see, okay, what is that point? So we use the intersection tool. And I have a way that I prefer. There are more than one method to use this intersection tool. My favorite intersection tool, if we go into menu, geometry, points and lines, I like to use in particular this intersection point because if you click on each function and it brings up that point. If you have two functions that intersect in more than one location, this tool in particular will give you all of those intersection points at once, whereas the other intersection tool, you will have to do the left bound, right bound in order to get each intersection point. So that's my favorite intersection tool. It's just like the one I prefer. So another way for the kids to go on and extend beyond that idea of, okay, now we know how to use evaluating at a value of X. We know how to check graphically. We know how to use the system solver, all to extend beyond that idea of evaluating a function at a value of X. So you took a 6th grade topic and you introduced it, and then you built upon it and built upon it and built upon it with the help of 2 pretty simple calculator files. Okay. All right. 8:30. I think I did pretty good with time. Josh, how'd I do?
Christine.
Look at that. I'm so proud of myself. Okay. So let me go back here. I'm going to stop sharing and send this over to Josh. Okay, Josh.
All right. Well, let me dig through here. Audrey, does that look to you like something I wanted to share?
Yes, sir.
Perfect. Okay. So folks, I wanted to, I tried to choose the activities and the lessons a little wisely tonight. We're going to talk about the S word here with statistics. And I chose some statistics activities for a couple reasons. In my experience, when talking with other teachers, if they have those favorite math subjects that they want to teach, that's great. But then if they also have that absolute least favorite subject that they want to stay away from teaching, if given the opportunity, it tends to be statistics. And with the revamp of curriculum over the past several years, statistics has kind of found itself into many of those other subject matters, Algebra 1, Geometry, Algebra 2 specifically, as well as in the middle grades math courses. So now a lot of teachers are forced to confront a lot of this curriculum where before they may have been able to steer clear of it. And I struggled trying to pick these specific activities because there were really just so many wonderful activities, both in the building concepts and the math-inspired libraries to choose from. So I settled on 2 of these. And this is the first one, which comes to us from the building concepts curriculum. And I picked this because I feel like the idea of probability might be, at least in a low level discussion with students, tends to be fairly understandable, but the idea of how do we model this and how would we simulate that, that is a whole different conversation altogether. And so as Audrey had pointed out when she looked at the documents and the resources online, this is the teacher document. The student document for the probability and simulation activity, 3 pages long, not that bad. the teacher document for the probability and simulation teacher notes, 24 pages long. So this is a very rich and robust document. And of course, ideally, it wouldn't be something that you'd have to print out. But what I really liked about this particular activity, again, focusing on some of the vocabulary, what is an outcome, what is probability, what is simulation, how we are going to tackle that. But the TI-Nspire technology skills are relatively simple to go through many of these statistics activities. It does talk about what each of these terms or buttons, you're going to find them to be on the screen, will do. I wanted to pull up the teacher document because this text and these questions are not found in the student document. And I felt like this activity, more than some of the others that I could have shared, really rests on the shoulders of the class discussion, whether it be small group, whole group, or what have you. And it just starts the students off thinking about a 10-question true-false test. You could get it right, you could get it wrong, if you were just guessing, okay? And so what do you think your chances of getting at least 60%? I find that to be an interesting question already, especially with it being the first question, because some students are going to not read that phrase at least. And so that in and of itself would bring in some good conversation. And Kylie decided to toss a coin to figure out her chances of getting 60% correct on a test. She let heads represent correct and tails represent wrong. So we're looking for the coin to land on heads here. And she recorded her results. Did she get a 60%? And of course, the answer would be no. And Peter said that this indicates the chance of getting 60% would be 0. And I think that that is a very common student misconception here. Well, she flipped the coin 10 times. She did not get it 6 times. So that probability obviously has to be 0. And so this allows the class, whether it be sort of teacher facilitated or just between student to student, the idea of these 10 coins being tossed to represent the 10 questions, that would be representing one trial. And how we should not rest the results of one trial or one simulation to be the end-all be-all of our statistics. So let's take a look at this activity. For this activity, you could see a coin. I'm not sure how well it translates with the shared screen, but there is a faint silhouette of heads here. But regardless of that, now this is something where, again, this activity has these questions there, but if I wanted to change this 10-question true-false test to a 7-question true-false test, this is exactly how easy it would be for me to do that, okay? Just clicking on those arrows, how many questions are we looking at? And then a toss. And this is tossing the coin 10 times because that's how many questions we have. So I think right there, after starting some conversation with the students, this is a wonderful place to enrich that conversation and discussion with the students. What just happened? Because I think that the first time they see something like this, it's not going to be very intuitive. Of course, we did in this one moment result in a situation where we passed with more than at least a 60%. Okay, we got 7 out of the 10 correct is what this trial would show us. We can continue tossing again. I know Michael had replied to some folks in the chat or the Q&A. All of this stuff is coded, just like the activity that Audrey showed. You don't have to come up with this number line and have the arrows with these draggable points. All of this stuff is done. All we have to do is click these buttons and wonderful math happens on the screen. We just have to be able to make sure that the right conversations and discussions are taking place. So this is showing us the repetition or the trial. I find that in most resources, we're going to see the word trial more often than not. And then this represents number of successes. So the first trial, we had 7 out of the 10 questions guessed correctly. And again, it's just true, false. The second and third trial, we had 5. Once you get to 3 trials on this particular document, you can hit 10 repetitions. And now it doesn't add a 10, it takes you to the next multiple of 10. And you can see that dot plot is being populated in real time. You don't physically see the coin being tossed, but I think at a certain point, the results of the coins being tossed is more important. And at any time, once these 2 buttons appear, you could also do 50 at a time. And so this is 100 trials of tossing a coin 10 times or tossing 10 coins, okay? And this becomes a little difficult once the number of trials, once the data is very plentiful, and that's where I'd like to show this show line, okay? Now this line, anytime you see something with an open hand on the Nspire, you're able to click and drag it. And what I'd like to point out at the moment is there is a number 1 that's not part of the line itself, in case it's not showing up very clearly on the shared screen. And this number 99 is kind of floating around. And as I drag this left or right, what happens now is that number 1 went from the very top of the line to the left-hand side. And you'll notice those numbers will start to change. And this is sharing with us. We can see that we have 100 trials. We've done this experiment or this simulation 100 times. And I'll pause there for a brief moment. We had 5 questions randomly guessed correctly 24 times. 34 times we had less than 5 questions, and 42 times we had more than 5 questions. And whenever you hover on or very near whatever the mean or the median of that data set is, it will also show up briefly on the screen until you move away from it. And I think that this is I can't make it, I'll have to hold it there. I think this is a wonderful thing to share with the students. Before I would show this line, does any part of the data look suspicious or crazy or out of the ordinary to us? And I think that most students would find this to be a fairly comfortable set of data, given that you should have a 50-50 probability with flipping a coin, if it's a fair coin, of course. And so the fact that the mean and the median are both around 5 out of 10 should not be surprising. If we wanted to answer that question, what's the probability that we would get at least 6 out of the 10 questions? This movable line is actually helping us answer that question because we don't have to count all of those dots. I could put that line anywhere between the 5 and the 6 and see that 58 out of the 100 times I did not get a 6 or higher, 42 out of the 100 times, or 0.42 would be the experimental probability. And that's what this activity is really designed to hone in on, the idea of theoretical probability given what we should experience, like a fair coin. We'll see a couple other theoretitional probabilities, and the idea of an experimental probability as a result of a simulation. So should a 0.42 probability or 42 out of 100 be out of the ordinary? In this case, I don't think that it is. Okay. Any, I forgot how much of the chat we see go away here, guys. So I'm counting on you to.
We're okay.
Okay, thank you. All right, so the first part of this probability and simulation document has a couple of different activities. This activity itself, I'm not sure that I would tackle this in one class period. I think that there is a very robust activity and there is a lot to come from it. So part one is talking about if we have a known situation, like randomly guessing on a true false, for example, what is our experimental probability? Part two changes, but I'm not sure because of time we're going to be able to get to that tonight. So here is another one where we are, I can pull up the teacher document so that we could talk about why this particular activity, okay? A basketball player typically makes 2 out of every 3 free throws she takes. What's the probability she will make 8 of her next 10 free throws? Okay, so given a question like this is something that you can't model with the toss of a coin. It has to, the tools that we use have to change now. And so asking students, which is what these other bulleted questions would indicate, what are we going to use to model this situation if we want success to occur with 2/3 of the rate? And one of the things we can model in thirds, or at least in sixths, is the toss of a dice. And so at the moment, this is going to toss a die 10 times, okay? So 10 dice, essentially. But a success is only going to be if it is a 1, and we don't want that to be the case. We want to extend our successes so that we can have a 2/3 success rate. And so all I'm going to do is click the numbers 2, 3, and 4. And this is going to give us a 4/6 probability for success, or which simplifies to 2/3. So when I do this now, it's going to toss 10 dice. And it does show it first few times to let the kids see what these numbers are representing. And I had 8 successes there. In this table, the successes are bright blue, and the non-successes, I don't want to say failures, it was just the toss of a dice. The 5s and 6s show up black, and we're going to do that again. On the right-hand side, it's exactly the same as we did with the true, false, and randomly guessing questions. The only difference is what tool are we going to use to model success in this probability experiment, and are we defining them to be appropriate, right? Why are we using n equals 10? Because the question prompt was, what's the probability that this basketball player makes 8 out of their next 10 free throws? If they were taking 12 free throws, 15 free throws, I could just change the number of free throws right there. Like before, I could change this to have a whole lot of data there, okay? And then showing that line probability that they would, now the way it's written, the probability that they would get 8 out of their next 10 is 35 out of 200. But as a sports fan, I don't care if the person makes 9 or 10 out of their next 10 free throws. It's kind of implied to me, even though it wasn't written in the question, at least 8 out of their next 10, and that probability would be 59 out of 200. Okay. I just want to walk through one more thing because I know some minutes are waning on us, but I do want to show a couple calculator tidbits in case it would be new information to anybody out there. We could do the same thing here with a spinner. So this particular spinner has a 10-sided spinner, and we could change how many successes we have, okay? And so we've got coins, dice, and spinners, and we can change what we consider to be a success. All right. Now, this is with a known probability and then simulating that. Part 2 of this same activity talks about, okay, so I've got a fair coin. What's the number of repetitions? How many times do I have to toss until I get 3 heads? And that's a very different statistics question, and it's a little bit more heavy, so I wanted to leave that for your own investigation, okay? So the other thing that I wanted to share with you guys, for those of you who may teach statistics, you may have done an activity before called random rectangles. And we really try to drive home whenever we are teaching statistics, randomness, 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 randomness. And students may be scratching their head, I don't know what the big deal is. So I want to share with you the gist of the activity and then 1 or 2 key features with the calculator on how you would do that. And the idea is this. This is a worksheet. It is linked in the Math-Inspired random samples activity. That was not the first place I ever saw this. And if you Google random rectangles, you're going to find 23 different links that will all produce this particular worksheet or something very similar. So the idea goes as follows. You pass this out or use a projector like I'm doing here. That would be a little harder, I think. So let's say you pass out a copy of this face down to all of the students and you give everybody 10 seconds. I want you to turn it over. I want you to look at all the 100 rectangles that are on here. And I just want you to guess what the average area of those rectangles would be. Okay. And then that guess would go in here. Could go around the room and collect data. There might be other ways to do this, but you collect everybody's guess. Are we guessing in the chat? No, just my troublemaker.
Just me.
Just
Sorry.
me. That's all right. Okay, so it's just a 10-second evaluation. I just want to guess what that average area would be. And then, okay, now let's take a couple more seconds. I want you to select 5 rectangles from this set of 100 that you feel best represents the entire group. Okay. And we're going to call this a judgment sample. If we did have a couple more minutes, boy, I would love to take all of these numbers that you're given here. Perfect. I love it. Okay. So step 2 of the activity would be you examine and you select 5 rectangles, and then you compute the average of those 5 rectangles. And that would go, like I said, into, it's called the judgment sample, right? And then we would use a random number generator to randomly select 5 of those rectangles for us. And then we go back and compute the area of those 5 randomly selected rectangles. And we check to see how they compare against the actual average. Okay. So before we do that, I'm going to back up because this is the calculator stuff that I wanted to share with you on this particular activity. If you didn't know it, if you open up a brand new box of calculators, put the batteries in and or plug them in and charge them up, and you ask students to compute a random integer from 1 to 6, let's say you wanted to simulate tossing some dice. Every student in the classroom would get exactly the same answers. And that is often a very weird and misunderstanding. And that's because of the way the calculator is programmed to select random numbers. So I'm going to work with the assumption that we've all kind of seen a random number table before. Imagine a giant random number table, and we just want to tell our own individual calculator an index or a starting point. And then from that point forward, it'll just move through the table selecting random integers. So if we're all kind of starting in very random different places, for example, 314159, you'll never guess where that came from. Okay, what we're doing is we're seeding the random number generator. Okay, and then if I wanted to do a random selection of numbers between 0 and 99, that's how the rectangles were numbered, 0 to 99. And I want to select them in batches or groups of 5. I want to select 5 random at a time. Now this won't do without repeats. This would be a good set for me. I would go back and I would grab those 5 rectangles, find its area, and that would go into my random. And I'm collecting data from students all over the room. And then we could look at their dot plots or box plots and see how they compare. Okay. In case anybody was curious, the mean was 7.42. Now you have that answer key. I'm pretty sure it's the same 100 rectangles regardless of which worksheet you use that you find online. Right? Excuse me. I'm sorry we weren't able to dive in with as much data so that you could see this activity sort of come to life here like we did with some of the others. We are running a little short on time, so I believe I'm going to need to hand things over to Mike to wrap things up for our webinar this evening.
Gosh, Audrey, thanks so much. As promised, we're giving away to one lucky winner a TI graphing calculator. And tonight's lucky winner is Curtis Crossley. So Curtis, congratulations. We'll be in touch over email next couple of days here to give you a little more information and get some information from you about what graphing calculator you're choosing. So congratulations, Curtis. That's awesome. Pick a good one. To receive a certificate of attendance, please click the link in the chat window, which is not for me. Give me 1 second. Let's try this again. Well, when I put that link in the chat window in a minute here, that link will get you your certificate of attendance as well as a link for the documents for tonight. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. If you're in need of any post-webinar follow-up, you have a question about anything, feel free to give us a call at 1-800-TI-CARES or drop us an email, ti-cares@ti.com. We'd love to hear from you. All right, certificate and documents link are coming, and I really appreciate, I think it was Josh that said, hey, no worries, you're automatically going to get these links again, and I agree. They'll be coming in email in a couple days. And that email, again, contains links for the certificate, the documents, and the recording so you can pause and rewind and go through at your own pace. It's really my favorite way to do this. When you leave the webinar, a brief survey will automatically appear in your browser, and we really appreciate your feedback and support. If there was something that you really liked tonight, let us know. If there was something that you really wish we would have done tonight, let us know that too. It really does help us plan future online events. Huge thanks to Josh and Audrey Viscucci for putting everything together for tonight. I really appreciate it, and I'm just excited that we were able to make this happen and that my audio got better.
Thank you,
thanks
Mike.
everyone else for joining us. And we hope to see Audrey, Aubrey, Josh, and everyone else next week. We'll be talking about coding next week, so feel free to hop on to our website, education.ti.com, select webinars, and check the upcoming webinars list. We hope to see you at a future upcoming live webinar. Have a great night, everyone. Talk to you soon.